These are your second set of notes for this week. This is notes 16. In the book, this is 5-3, page 280. Make sure you've got your name, date, period, and everything set up. We should have the warm-up problem solved already. And let's go ahead and get started. This is proving that a quadrilateral is a parallelogram. So all the different things, and there's a lot of different reasons why a quadrilateral could be a parallelogram. So we're going to have kind of a chart set up for today's notes. It's based off of a concept summary on page 285. So if you also want to look in your book at page 285, that might help you. So go ahead and set it up like this. This is the first method. So again, this is page 285, proving that a quadrilateral is a parallelogram. So if you have a quadrilateral, it may or may not be a parallelogram. It's a parallelogram if, this is one way, if you can prove that both pairs of opposite sides are parallel. That's based on the definition of parallelogram. So there's a lot of different ways you could prove this. It might be given, you might see it, you might be able to prove it, but what it would look like if both pairs of opposite sides are parallel, it would look like this. You have the left and right sides parallel, and then the top and bottom parallel. So you have those little arrow markings showing that they're parallel. And again, this is just based off of the definition of a parallelogram. Okay, and pause if you need to, but I'm going to start showing the next one. So here is another way to prove that a quadrilateral is a parallelogram. We can prove that both pairs of opposite sides are congruent. So we've got to prove that both pairs of opposite sides are congruent. So remember, congruent marks are different than the parallel marks. The parallel marks are the little arrows. Congruent marks for sides are the little lines. So I would have opposite sides congruent with one mark. It doesn't matter which one's one, which one's two, but they have to match up. Top and bottom match up. They're congruent, and left and right match up. They're congruent. And that's based off of theorem 45. Again, pause whenever you need to. So here is another method. Again, you can just do any one of these. As long as you can prove one of these, then you are proving that the quadrilateral is a parallelogram. So let me just move this a little. Whoops. Okay. Okay, so for this next one, prove that an angle is supplementary to both of its consecutive angles. So remember, supplementary means that it adds to 180 degrees. And this is based off of theorem 46. And so I'm just going to show for an example, let's say that one angle is 100 degrees. Whoops, that one wouldn't be 100. All right, just kidding. So I whited that one out. So this angle would be 100 because it's an obtuse angle. So 100 degrees there. If it's supplementary to both of its consecutive angles, both of the angles which are next to it, their consecutive angles, would have to be supplementary. So I would have to do 180 minus 100 to check. That would be 80 degrees. So both consecutive angles would have to be 80 degrees. And that one would be 80 degrees also. So that's what this one means. Prove that an angle is supplementary to both of its consecutive angles. If we know one of them is 100 and then we can prove that the other two are 80 degrees, then this would be true. That's theorem 46. All right, here's another one. Again, pause as needed. So prove that both pairs of opposite angles are congruent. So you can see I accidentally wrote sides because there is one up here about opposite sides. So you could prove from up above that both pairs of opposite sides are congruent, or for this one, that both pairs of opposite angles are congruent. So remember, the way we mark angles congruent is with arcs. This is based off Theorem 47. And the way we show this would be one angle would have one arc. The angle opposite is across. The consecutive angles should be supplementary, so they're different. I'll do double arc there and then a double arc here. And that's really all that it is. Opposite angles are congruent. Prove that both pairs of opposite angles are congruent, and it would look like this. All right, and again, pause it if you need to. I'm just going to keep going. That way you can move at your own pace. So here's the next way, the next method to prove a quadrilateral is a parallelogram. You can prove that the diagonals bisect each other. So for this one, I need to get my ruler and draw the diagonals. Diagonals just go from one angle to the opposite angle. So like this. You don't have to make it perfect, but I do want you to see how you can do it if you have a ruler. And the other diagonal goes from one angle to the opposite angle, like that. I feel like it kind of looks like a kite when you do that. So once you do that, we're going to think about how can we show diagonals, which are the lines, not the angles. The diagonals bisect each other. Bisect means that they cut it in half into two equal segments. So if this shorter diagonal is bisected, it's got a 1 mark and a 1 mark. Those two are congruent. And then across the long diagonal, we've got 2 marks for congruent, and match it here, 2 marks for congruent. So that's what it would look like. Along the same diagonal, they have to have matching congruent marks. Either 1 and 1 or 2 and 2. It could even be like 3 marks and 3 marks, but the diagonals have to be bisecting each other so that the center would be the midpoint. The center would be the midpoint of each diagonal. Okay, I'll even put a little point there. Okay, and then here's the last way. The last method is to prove that one pair of opposite sides is congruent and parallel. This is Theorem 49. So we'll only be looking at one pair of opposite sides. It can either be like top and bottom, or it could be left and right. So one pair of opposite sides is congruent and parallel. And we mark this a special way. We would have congruent marked with one little line mark, and then parallel will be an arrow, like that. So it's like a line for congruent and an arrow for parallel. Okay, so pause if you need to, go back if you need to, but I'm going to move on to the bookwork, page 282, 284, and 286. All right, so I am starting on page 282 for the bookwork, and remember you will need to turn in pictures of these with your notes for the whole week. So on 1 and 2, it says, for what values of x and y must ABCD be a parallelogram? So we have to think about all the methods that we just wrote down in the notes. Looking at the diagrams really helps also. And I can see on number 1, remember that if we have only one equation, we need to have the same letter, the same variable. So if I'm trying to do consecutive angles or supplementary, I could do 3x plus 3y equals 180, but that's 2 different letters and I can't solve it. So what I'm looking at is the opposite angles have the same letter. So if the opposite angles have the same letter, I have in my notes that opposite angles are congruent. So if this is a parallelogram, the opposite angles must be congruent. So 3x must equal 4x minus 21. And then the other ones would be 3y equals y plus 78. So again, I'm looking at, I'm trying to see how can I match up the variables so that I have the same variable. So they're not consecutive, which would add up to 180. They're opposite. Opposite has the same letter, so opposite angles are congruent if it's a parallelogram. After that, I just have to solve. So I'll subtract 4x and I get negative x equals negative 21. Divide by negative 1. X equals 21. And then over here, I would subtract y. I get 2y equals 78, divide by 2, and y equals 39. So to answer the question, it says, for what values of x and y must ABCD parallelogram be a parallelogram? So x would have to equal 21 and y would have to equal 39 for ABCD to be a parallelogram. So that's the answer. X would have to equal 21 and y would have to equal 39. Okay, looking at number 2, it deals with the opposite sides. It does show a diagonal and angles, kind of like if it's parallel lines cut by transversal. So let's keep that in mind. Why is it showing me this? Because they're alt interior angles and they are congruent. So actually, I'll just mark that right now, that that side is parallel to this side. So one set of opposite sides is parallel. In order to be a parallelogram, looking at the notes, I also have to prove, I know it's hard to see, but this last one, prove that one pair of opposite sides is congruent and parallel. So I only need one pair, but they have to be both congruent and parallel. So I already know that one pair of opposite sides is parallel. Let's see if they're congruent. So to be congruent, 5x minus 8 would have to equal 2x plus 7. And I would just have to solve and see for what value of x would this be true. So subtract 2x, and then I would add 8 to the other side. So 5 minus 2 is 3x, and then 7 plus 8 is 15. Divide by 3. X would have to equal 5 for A, B, C, D to be a parallelogram. So that way we would have that last method in the notes. We would have opposite sides to be both congruent and parallel. That's what it would look like. They have to be parallel because alt interior angles are congruent, so those lines would be parallel, and opposite sides are congruent. Okay, so now I'm going to move on to page 284. It's really similar, except now we don't have to solve. It says, can you prove that the quadrilateral is a parallelogram based on the information? Explain. So for number 3, I'm looking at opposite angles are marked. So I do have opposite angles congruent and opposite angles are congruent. So I can say yes. I'm going to look at my notes so that I write it the right way. So I'm looking to see right here. Prove that both pairs of opposite angles are congruent. That's what I have to write. And see how it even looks like that diagram. You want to see if it looks like one of those ones that we did. Yes, it is a parallelogram because both pairs of opposite angles are congruent. Okay, so yes, it is a parallelogram because both pairs of opposite angles are congruent. And that was one of the theorems that we put in the notes. It was theorem 47. All right, looking at number 4, let's see, there's only one thing marked. It is right here. One diagonal bisects each other, or bisects itself. I don't know. That's almost like this one, theorem 48. Prove that diagonals bisect each other, but it has to be both diagonals. It's only one diagonal, so it doesn't look like this. It's missing the other diagonal being marked. So I would say no, I can't prove that this is a parallelogram because only one diagonal is bisected. Okay, so again, pause if you need to finish writing that down. I'm going to just show you real quick. This is the concept summary that we copied in the notes. So this is all the reasons, again, all the methods and the diagrams. So you can also look back at it right here on page 285. All right, and then we have just a few more problems to practice. So page 286. Okay, so it says, for what value of y must LMNP be a parallelogram? So I can see y would be this angle right here. And I see that opposite angles are congruent. It's 68 and 68. So I want you guys to think, how would you find this missing angle? It's one of the consecutive angles. Consecutive is the one that's right next to it. So if you're not sure, let's look in the notes. That's where you can usually find your answers. You can even look at the pictures and see which one is similar. I can tell this one is kind of like it because it actually has numbers in for the angles. So it says, prove that an angle is supplementary to both of its consecutive angles. So supplementary means that they add to 180, and I even did a little example right there showing how you do 180 minus the one you know, and that gives you what the other two would be. So that's what I'm going to do here. 180 minus 68, and I get 112. So y must equal 112 degrees for LMNP to be a parallelogram. If it's not 112, then this would not be a parallelogram. All right, and then for these next two, it says, is the given information enough to prove that ABCD is a parallelogram? And explain. So looking at 7, I don't know what the actual angles equal, but I do know that those two are congruent, 2y and 2y, so I can actually show little arcs. And then those opposite angles are congruent, x and x. So I can actually mark that they're congruent, and I can see that, yes, that is actually enough information. Yes, both pairs of opposite angles are congruent. Both pairs of opposite angles are congruent. So that one did have enough information. Again, even though it's not giving me the actual numerical values, I know that this expression 2y is congruent to this expression 2y, and x is the same as x. So they are congruent. So opposite pairs of angles are congruent. All right, look at number 8. So we've got this quadrilateral ABCD. It's got this point H, and then it has these markings on the diagonals. So I'm going to get my notes out and compare to these diagrams. It looks kind of like the one that's almost last, this one. So compare, are those marked the same? So along one diagonal, I have the same marks, and along the other diagonal, I have the same marks. That's what it must look like. But I don't have that here. I have one mark here and then 2. And then across the other diagonal, 1 mark and then 2. They don't match like how they do here. So this one is actually a no. So is the given information enough to prove that it's a parallelogram? So no, this isn't enough information because the diagonals do not bisect each other. Okay, so that's it for the book work. Make sure you take pictures of that and turn it in when you turn in your notes. Make sure your notes are finished with 3 questions on the left and a summary for full credit.